Welcome everyone. In this tutorial, we will learn how to build a binary QSAR model using the ChemMaster software. So binary QSAR is a type of classification QSAR in which you are using two classes. So basically, the binary QSAR model will give you a class for the activity rather than a numerical value. So for example, it will classify compounds as active or inactive rather than giving a numerical estimation for the activity. So first thing is that I will import the dataset for modeling. So from the file menu, select import structures. You will find the dataset attached in the description. So click open and I have imported the dataset. So this is a dataset of 70 compounds of CDK2 inhibitors, the cyclin-dependent kinase enzyme. And here I have the IC50 in the nanomolar unit. So the first thing is that I need the activity to be a categorical variable, meaning it should have labels for the compounds rather than a numerical value. And you can do this in the ChemMaster software. From the table menu, select Add Categorical from Numerical. So this functionality helps you to add a categorical column using a numerical column values. So basically it will create ranges and the compounds that lie within the range will be labeled in the corresponding class. So here the column that we want to use is the IC50. And for the number of classes, we want to use 2 classes. And here we can specify the range for each class or the bin limits. So we can automatically set this as equal population or equal width. So for example, the equal population, try to make ranges automatically such that the number of compounds in each class is approximately the same. We can also manually specify them. So here I will create the first class as the highly active and compounds within the range of the minimum to, let's say, 100 nanomolar to be highly active, and for the rest of the compounds I will label them as low to moderately active. Of course you can use a different range, but I use this range as it gives us somewhat balanced classes, and usually you want your classes to be as balanced as possible, although it's not always practically possible. So I'll call this column as the activity class and click OK. So now we have added the column for the activity class that we will use in the binary QSAR modeling. So basically it labels each compound as highly active or low to moderately active. So this will be the Y variable, and we also need the X variables, which are molecular descriptors. So I will use the max structural keys. From the calculate menu, select max structural keys and select all structures and click OK. So now we have calculated the descriptors, which will be used in building the model. So to build the binary QSAR model, from the QSAR menu, select binary QSAR and click on build model. So the first thing is we specify the X and Y variables. So for the Y variable, we select the activity class, which we just created. And here which class to be considered positive and which one to be considered negative. This is related to calculating the validation parameters, which will we see later. Usually the positive class is the active or highly active, and for the negative the low to moderately active or the inactive. And for the X variables, we'll select the max keys that we calculated. I will select all of them. And next for the dataset division, we will use a random division of 70% as training set, and we'll keep the random seed the same to get the same division. And this option, which is called stratified, now this makes sure that the classes ratio is balanced in the training set and in the test set as much as possible with respect to the ratio in the whole dataset. So usually it's a good idea to always check this so you can get a balanced class ratios. Although the training and the test set will be randomly selected, but this tries to keep the classes ratio balanced. Next, we'll specify the model settings. So for pre-processing the X variables, we'll keep this default as well as for the feature selection. This will help to remove the descriptors with low variance, meaning constant or near constant descriptors. Now as for the method, which is the machine learning algorithm, you can select one of several methods. Here we'll select the support vector machine. This is a powerful classification method. And from the settings, you can specify the hyperparameters of the algorithm. You can either manually or select auto. Now this auto option will try different parameters and select the best based on a cross-validation procedure. You can read about this from the help menu. So we will use the default parameters here. And for the k-fold cross-validation, if you check this, after obtaining the final model, a cross-validation procedure will be performed and the validation parameters will be calculated on the result of the cross-validation. And here you specify the k-fold, the number of folds in which the data will be split. And finally, I will call this the SVM model and click OK to build the model. So now the model has been built, and here we can see the validation parameters for the training, test, and the cross-validation. So here we have the common parameters such as the accuracy, sensitivity, specificity, and so on. And you can see the equations that are used to calculate those parameters from the help dialog. So from the validation parameters section, you can check the equations and the meaning of each one. So for example, the accuracy gives you the overall accuracy of the model. And usually for the training set, the parameters are not reliable, especially this is not a large data set, but we can see it has good results for the test set and the cross-validation. And here we have the confusion matrix. So basically this is the actual positive and the positive predicted by the model, and the same thing for the negative class. Now the columns are what predicted by the model and the rows are the actual. So here we have 21 compounds for the training set that are positive and were predicted as positive. And you can also see the test set confusion matrix. So for example, in this cell we have one compound that is actually positive but was predicted by the model to be negative. You can also read about it in the help dialog in the confusion matrix section. And here we have the information of the model. So first the X variables, the number of features and the names of the features used by the model. And then we have the Y variable information such as the name and the label of the positive and negative classes. Also the machine learning that was used and the values of the hyperparameters. And finally the k-fold cross-validation, the number of folds that was used. So you can export this model to use it later on for predicting other compounds, such as in virtual screening. Simply right click on the model and click export model. For example, I will call this the SVM model and click save. So this concludes our tutorial on how to build a binary QSAR model using the ChemMaster software. The ChemMaster is a free software. You can download it, the link is in the description.